For a long time, running AI meant choosing between serious capability and owning your own hardware. That gap has practically vanished. Highly compressed open-weight models have closed the distance. Today, a model like Llama 3 70B performs on par with GPT-4o on structured coding and reasoning tasks. This creates a direct engineering dilemma. You can pay $0 upfront to rent a cloud API, or you can invest thousands of dollars into a workstation to run the model entirely on your own hardware. Pick the wrong path for your specific workload, and you risk a compounding monthly bill from API costs, or a loss of development speed while managing GPU drivers and hardware failovers. We are going to skip the hype. We are going to look strictly at hard latency benchmarks, actual token math, and proven enterprise deployment patterns. This comparison matrix shows how local hardware and cloud APIs stack up across 4 metrics: cost, latency, capability, and privacy. This architectural choice determines your long-term margins and how quickly your agents can actually respond to users. Cloud APIs are attractive for early-stage prototyping because they cost nothing to set up. This graph tracks how costs scale. The cloud API line climbs steeply. Past 2 million tokens daily, cloud pricing becomes a compounding liability. A flat line representing local hardware appears. Despite a high initial investment, ongoing costs stay flat, making it 18x cheaper at scale. But there is an ops tax. Maintaining local hardware requires 4 to 8 hours of engineering time every single month just to handle driver updates and failover planning. Cloud is a quick start that carries a penalty at scale. Local is an expensive upfront bet that pays off after 2 months of high utilization. On the speed side, physics dictates cloud performance. Sending a prompt over the internet adds 100 to 500 milliseconds of network round-trip time per call. That delay becomes a major problem in agentic loops, where an AI model executes multi-step reasoning. That network penalty multiplies with every sequential step the agent takes. Local hardware eliminates that network trip. You get sub-20 millisecond latency, which is required for real-time voice agents or rapid sequential reasoning chains. Where the cloud pulls ahead is horizontal scaling. If you need to process 10,000 documents in parallel, cloud infrastructure handles them all at once without requiring a massive rack of servers. Local hardware works for real-time, sequential speed. Cloud infrastructure is for massive parallel throughput. Looking at capability, highly compressed 4-bit quantized local models now handle standard coding workflows and logic tasks, but they have limits. For tasks that require a million-token context window or complex multimodal analysis, cloud frontier models still lead. Because of these trade-offs, 55% of enterprise organizations use a dual deployment architecture. This is hybrid routing. Teams push 60 to 80% of their high-frequency tasks to local models and reserve cloud calls only for complex edge cases. This setup maximizes cost efficiency and intelligence, but it requires orchestration software to correctly manage the traffic between the different models. You can access peak intelligence while controlling costs. Your team has the operational discipline to build and maintain the routing infrastructure. Major cloud providers offer SOC 2 compliance and zero retention policies, meaning your prompts are not used for training their models. Despite these protections, transmitting protected health information to shared cloud infrastructure is often a compliance failure under frameworks like HIPAA and GDPR. The alternative is an air-gapped local deployment. By running the model yourself, sensitive personal data never leaves your physical network perimeter. Running a model locally does not make it automatically secure. Keeping data on-premise places the entire burden of access control and prompt injection defense onto your own team. In regulated industries like healthcare or finance, data sovereignty is a legal baseline that rules out most cloud options entirely. This flowchart identifies which deployment matches your constraints. Handling protected health or financial data, local deployment is legally required. If volume is low and speed prioritized, start with cloud APIs. If volume crosses 2 million tokens with deep agentic loops, use hybrid architecture. To maintain this split, teams use orchestration layers to sync context, ensuring the agent doesn't lose track of the conversation when a task moves from local hardware to a cloud API. Choosing the right deployment means matching your organization's scale and legal limits to a specific architecture. One requirement remains identical, whether your model runs on an AWS server or an RTX 4090 under Nordesk: observability. Without tracking token usage, latency percentiles, and error rates, a deployment can fail unnoticed in production. Whether you rent the brain or buy the hardware, your infrastructure only provides value if you have the metrics to prove it actually works.